How about now? How about now? All right. Do you know what it is? It's because I was recording some videos. Joe, when I record for like other things on YouTube, you have to like split the timeline so that when you upload your video to editing uh applications, it splits the audio from the PC to your mic, but then I forget to change it back. But yeah, I was saying, yo, what's up, Nathan? You're resitting. Time to lock in, my guy. For real. Nathan, are you on my main course or are you just doing self-study? Yo, SV, good stuff, my guy. Joining the main course after my other stream. Ibs, what's up, Ibrim? 10 out of 10, 10 out of 10. Yo, Ishmael, Pranav, my guy, is back. Who else we got? Yo, Rayan. I'm talking to myself. Marzin, what's up? Car spotting, of course, I remember. So, just doing a little cheeky trial stream for you guys. I think a few of you going into year 13 want to see what it's like to be on a Mired Space course. There's also an opportunity for you guys to ask me any questions you might have. I thought I'd do something more interesting. There's a topic we'll do in October. There's the addition formula in it, so it'll be a banger. Hey Angela, how's it going? Zed is not looking good, Mike. SV, do I decide when the year 10 course starts? It's like a group thing. It's the whole of my space, so it's starting next week. Yeah. So guys, if you think this stream will benefit anyone else, make sure you share it with them if they're going into year 13 maths. Yeah, be a supportive friend, be a supportive family member, share it with your pets and that. And then I'll introduce myself. Stats got you in a chokehold, Nathan. Ayo, for real, stats can be a mad one sometimes. Now, why should you trust me? If you've not been watching a ton of my content already, got thousands of hours of free content for you guys, but just to classify my credentials and that. I'm the head of maths at my headspace. I've got a first class honors degree in mathematics from UCL. I have over 9 years of qualified teaching experience and experience as an examiner. And I'm the ex-head of A-level maths at multiple schools in North Wheezy. I'm stacked with maths, for real. Jaff, what's up? Who's this geezer? It's every exam board, Rayan. Thank you, Zed. 1-1 cold. That'll be you guys soon. So, what is the addition formulae? Okay, well, you guys are very used to expanding brackets, right? Yeah, basic stuff. Now we're going to look at things like, oh no, don't tell me the thing is bugged. Hey, yo, guys, look at this. This is why I don't like other teachers using my graphics pad because they mess everything up. But what some students think is when when they see something like cos of x plus y, I need to open up the, what is it? The XP Pen graphics pad application. I'll do that in a sec. So what students think is they see cos of x plus y and they think you just need to expand the bracket. Okay. But that's not true. And we can prove that or disprove that using examples. Okay. So from GCSE, let's let x equal something and y equal another angle. Do you guys remember from GCSE which angles are the ones you need to know? I'm just going to check my XP pen. Let's see if I can change my active area because this is so annoying. Let's do all monitors. Okay, I'm going to see if this fixes it. Oh, it does fix it, but it's a bit buggy. Okay, guys, you're going to have to forgive me here. So give me angles that you knew from GCSE. SV 30, good. Now we could do the same one twice. Yeah, let's do 30 and 60. I think that's a good one. Hey, Anaya, what's the best calculator for further maths A levels? I don't think it matters. The 991EX, in my opinion, is still the best calculator if you can find it. Otherwise, just go for the CG50. Z, yes, you can use your calculator. All of this. Year 13 A-level maths is calculator stuff. So if we let x equal 30, y equals 60. If we look at the left-hand side and the right-hand side separately. Now the left-hand side, we have cos of 30 plus 60, which is cos of 90. Now hopefully you know what this is, but you can use your calculator. Cos of 90 is 0. Yeah? So the left-hand side is 0. The right-hand side, we have cos of x, which is 30, plus cos of 60. Is that equal to 0? Yes or no when you add these two together? What's up, K? So cos of 30 plus cos of 60. Is that equal to 0? I'm his son, you know. L740. No, good. It's not. Okay. L740 sounds like a Black Ops weapon. So cos of 30 is root 3 over 2. And cos of 60 is a half. So this adds to root 3 plus 1 over 2, which we can clearly see is not the same. So immediately we know that the right-hand side and the left-hand side are not the same. So we can't just expand brackets when it comes to trigonometry. Okay? I'm going to show you what it actually is. Okay? So I'm going to show you what sine of x plus y and cos of x plus y are using these double triangles. Okay? So I have triangle 1, yeah, which is a right-angled triangle, whereas angle is at x. Then I have triangle 2, which is also a right-angled triangle, whereas angle is y. Okay, IBSI was just an example. Just an example. It says prove using a counterexample, so you just give an example where it's not true. Okay. So I have two triangles, two right-angled triangles on top of each other. Now, if I want to find sine of x plus y using these triangles, I need to form a right-angled triangle, okay, where the angle is x plus y. Here I have x, here I have y. I need to somehow draw a right-angled triangle within this big shape that has x plus y as one of its angles. Does anybody know what line I need to draw to form a right-angled triangle with this as its main angle? I just need to draw another right-angled triangle so I can then do sine and cos. But I just need to draw one line to form another right-angled triangle. Where would that be? Where would I need to draw Inaya? A straight line? How would you draw the straight line? Because there's loads of ways I can draw a straight line. You know, it could go down like this. But I need to somehow form a triangle at a relevant place. L740, good. From the vertex down. Okay. Nice, Anaya. So from the top here, yeah, guys, with a ruler, with your workbook, draw a vertical line straight down. Okay. And this is the right angle we are going to be observing. And we need to find all the lengths as part of it. Okay. So we're going to be focusing on this right angled triangle. Okay. Now remind me, guys, in a right angled triangle, sine is what divided by what? So sine is what divided by what? Remind me. SV, Scorpex. Yo, Karthik. Good. Opposite over the hypotenuse. But when you look at that triangle, hey, Prisha, that I just drew, what is the hypotenuse? What is the hypotenuse? All right, Anaya, all good. I'll still see you around on my videos. Scorp, good. Ibs, good. 1. Guys, look at this. Remember, this is my triangle that I'm observing. The hypotenuse is the one, again, opposite the right angle, right? It's 1. which means since sine is opposite over hypotenuse, yeah, if sine is the opposite over the hypotenuse, if the hypotenuse is just 1, it just means sine of the angle is just the opposite side, okay? So this length here is sine of x plus y, okay? So that's why I need to work that out. And cos is going to be the adjacent side, okay? So that's going to be cos, and that's going to be sine, okay? So let's do that. Once we do that, we have formed the proof, all right? So I'm going to help you guys out. Using SOHCAHTOA, I want to find this length. Okay, that's the length. My graphics pad is bugging, unfortunately, but I want to find out that green length. If I was to redraw it, yeah, it looks like this. There's a right angle, there's 1, there's y. I want to work out this length. Now, assuming you guys are year 13s, you should be able to tell me that length very easily. Who can tell me what that length would be? It would be in terms of y. Remember, this is the adjacent side. And this is our hypotenuse. What would that length be? Assuming SOHCAHTOA should be quite basic for you guys at this point. L7 is definitely at that point. Okay? Yo, it's on. Yo, bro's back for more maths. That's crazy. But it is cos y. Okay? Because the adjacent, right? Because that's my adjacent. So I'm saying cos of y is the adjacent divided by 1. Yeah, which is just cos y. So this length is cos y. Okay? Cosy. Using that logic, what do you think this length is going to be then? What's that length going to be? Old school student. Guys, this graphics pad is really annoying me. What would this length be over here? Using that same logic. That's going to be the same as this one over here. So that's now in the opposite side. The hypotenuse is still 1. So if this side here is cos y, what must the opposite side be? Keeping it simple. Simples. Well, I think YouTube's bugging. But it'll be sine y. Using the same logic. There you go. Thanks, L7. We're basically doing private tutoring right now. Which is all good. Bringing me back to my old days. Okay, so we filled out all the lengths on this second triangle. Now we can go to triangle 1. All right. So looking at that triangle. With this being cos y, there's my right angle. This is now x. I guess I'm asking L7 this only. What would this length be? L7. Let's see if you can get that. That's the adjacent. And the hypotenuse. So we already know what the ratio is with A and H. It's just the hypotenuse has changed. SV, the hypotenuse is not 1 anymore. Nice, L7. So cos of x this time, cos of the angle x, is the adjacent divided by the hypotenuse, which is cos y. So you can multiply through. The adjacent is cos x, cos y. Okay? So this length over here is cos x, cos y. Now we just need to do the opposite. Oh, what's that one going to be? Maybe I can draw over here. So that's my opposite. My hypotenuse is cos y. And this is x. So O and the hype. Using a different function this time. Ibs is definitely sine. But it's not y. The angle here we're using is x. Yo, Aiden. Good shout, Aiden. Well done. Thanks for joining as part of this conversation. So sine of x is the opposite over the hypotenuse, which is cos y. So you multiply through, the opposite side is sine x cos y. Okay? So I'm just going to free up some space here. So this vertical side is sine x cos y. All right. Now we're basically done. We're very close. Now remember, I told you guys that I wanted this vertical side to tell me what sine of x plus y is, isn't it? Now we already have part of it. We have this sine of x cos of y. Yeah, so we have part of it. We are just missing the other vertical length. We're missing this other. You don't need to draw this just yet. We're missing this vertical length here. And to find it, we just need to draw another right-angled triangle. And it's part of this yellow line here. We draw a vertical triangle here. Okay. So this is just the last right-angled triangle we need to draw. It's an interesting geometry problem we've got here. All right. So here, this is the third triangle. Yeah, this is the third triangle. We have sine y as its hypotenuse. But we are missing an angle. Now, using your alternate angles, corresponding angles, do any of you guys give me an angle within that triangle? Can any of you guys see an angle within that triangle? Either at the top or at the bottom here. So you need to use like your Z rules, your F rules, your U rules, one of those. So either the top angle is either X or Y, or the bottom angle is either X or Y. So you'd have to specify. AOL7, your contributions were good, man. Your contributions were very good. Thank you very much. Hopefully I won't be narrating to myself. But I'll give you guys like a couple seconds. So the angle that we want here, Romeo, you're very close. I know which angle you're using here. So you're using X and you're using your Z rules. And you're saying this bottom angle here is X. Okay. But if that's X, then this is 90 minus X. Which means the top angle is actually X here. Okay, so you're right, that bottom angle there is X, but that's outside of the triangle. So the internal angle, like, I don't even know how to say that, but you're looking at the internal angle is X. Okay. Now from here, we just need to work out the other lengths doing the same thing. So this is the hypotenuse. This here is the adjacent. So remind me, what are we using when we look at the adjacent and the hypotenuse? Which ratio involves the adjacent and hypotenuse? Yes. Name. Help me describe your name because I don't know what to say, to be honest. So we have cosine of x is the adjacent side which we're trying to find, divided by the hypotenuse, which is sine y. Okay? So the adjacent, when we multiply through, is cos x sine y, or sine y cos x. Okay? Bazira. Okay. for 0. Thank you very much. So sine y cos x. All right, so that's that length. Okay. Then finally, we need to do this adjacent side, which, sorry, the opposite side. Now, the opposite side is sine, right? So we have sine of x is the opposite, divided by the hypotenuse, which is sine y. So we just multiply through. We get sine y sine x. So this length here, guys, is sine y sine x. And now we are done. Okay. So now we can work out what sine of x plus y is. Because remember, guys, sine of x plus y, did we say that was the vertical length or the horizontal length? Jump in the original triangle in the green one. Right at the beginning, what did I say? Was it in this original triangle, is it the vertical length is sine or was it the horizontal length? Which one was sine? In this triangle I've just drawn. When we drew that vertical line. Because here's your x plus y. SV, yeah, it's the vertical. Okay. Now that vertical is made up of sine x cos y, sine y cos x. And this is the expansion for sine of x plus y. Okay. So we have sine x cos y plus sine y cos x. Okay? And this is our first addition rule. It's pretty cool. The last one is cosine, which I have to write here. Cos of x plus y. Now remember, cos of x plus y was the horizontal. But the only horizontal lengths I have is this one and this one. Do we need to add them or take them away to get that horizontal? Look what I'm highlighting in blue now. These two lengths, do we need to add them or subtract them to get this horizontal length? Take away, good. Because cos x plus y for 0, good, is that full big length. Cos x, cos y. Then we take away this one over here. Sine x, sine y. All right, and that is our other addition rule. Now, just as a bit of a key takeaway here is I'm not the kind of teacher who just says a rule and then doesn't prove it to you. I've proven to you where the addition rule comes from, but they wouldn't ask you to prove it in the exam. But I prove it because it builds trust. And I'm all about trust when it comes to teaching. If I just told you that this is not true, I said this is not true, and I said this is true, you'd be like, what the hell, dude? That doesn't make any sense. Where are you getting that from? Okay? So I prove it to you, but then we utilize it in practice. Man like Alex, you remember. So I have ways of you remembering these anyway, okay? They're very simple. So, use your expansions for sine x plus y and cos x plus y, which we just proved, to do the other ones, okay? Now, Alex has given you guys a way to remember the cosine formula. So, I call it the couscous formula, okay? It's called the couscous formula. If you guys don't know already, couscous is a food, yeah? It goes cos. So it looks kind of like couscous. X and Y. So the angles here are X and Y. It goes couscous, sine. Yeah, X and Y. When you realize the pattern, it's actually very, very simple. Okay? Then all you need to remember is that cos changes the sign. It just becomes minus. Because remember, we subtracted to get that horizontal length. Okay? Then sine goes sine, cos. Yeah, it goes sine, cos. XY. Then all that happens is we switch the angle, YX. Sine keeps the sine the same. Okay? So guys, sine goes sine cos sine cos. Cos is couscous. Is very simple to remember. Okay. Now, using that logic, I'll prove it a slightly or show it a slightly different way in the main course. What do you think sine of x minus y is? What do you think sine of x minus y is then? SV, exactly. Yeah. Sine cos, sine cos, sine cos, sine cos. Yeah. It goes xy, yx. Sine keeps the sine the same. How about cos x minus y? Our famous couscous formula. What's the couscous formula saying? So SV, Farham, exactly. And SV, good. So guys, couscous. Cus. Yeah, sine. If you say it the same way as I do, it's very easy to remember. XY. Cos changes the sign. Easy. So at first, the formulas look weird. Yeah, but guys, it's very easy to remember what they are. Yeah. We don't need formula booklets. Yeah, guys, if it comes to a point where you need a formula booklet, you've not done enough revision. Yeah. It means whatever grade you get, fully deserved. Okay? Fully deserved. But it's not going to be you guys. Well, especially if you're on my main course starting next week. All right? You won't need any formula booklets. Yeah, it's not looking good, Mike. So, use your expansions for sine x plus y, cos x plus minus y to find a similar expansion for tan x plus minus y. Okay? Now, remember, guys, tan is equal to what over what? What's up, Yusuf? Why is my head so... It's because I'm leaning back, that's why. So sine over cos, good. Opposite over adjacent, yes, where opposite is the sine function, adjacent is the cos function, okay? So we get sine x plus y over cos x plus y. Okay? Now, we can simplify this pretty nicely. For some of these, you're going to leave a bit of gaps. Now, I'm going to ask you questions to help you remember what the expansions are. How do you remember what the expansion for cosine is? Couscous. There you go. Okay. When you remember couscous, it's nice and easy because then you know this goes sine. Yeah. XY. Cos does what to the sine? Cos does what to the sine? Cos does change. There you go. Yeah. Changes the sign. And the expansion for sine, how do I aid you guys in remembering that? Yo, Vegetia. What's up? Welcome to year 13 maths. How do I always teach you not couscous? It's kind of like I say it with the layout. What's the layout? Wait, what was your name? Was it Bazira? You're not wrong. So the way I helped you guys remember is I said sine cos. Okay. Now leave a bit of gap. I should have done it a bit nicer here. Leave a bit of gap because of what we're going to do next. So it goes sine cos, sine cos. Okay. xy, yx. Sine does what to the sine? Yo, Devia. Yo, Golden State Warrior. Good, Romeo. Sine keeps the sine the same. Easy. Now, it'd be weird to have the tan expansion in terms of sine and cos, okay? We want it in terms of tan. So all we need to do is we need to divide every single term by something that is going to change everything into tan, okay? For example, if you just focus on sine x, what would you have to divide it by to turn it into tan x? What would you need to divide sine x by to change it into tan x? Cos x. Good. So specifically cos x. But you can't just divide this by cos x. You have to divide everything by cos x. Okay. Similarly, if you notice over here, there is a sine y. In order to turn that into a tan function, you have to divide by tan y. By cos y. But you have to do that everywhere. Okay. And now this is going to simplify really nicely. Okay. This first one, what does that simplify to? This one here. What does that simplify to when things cancel? Topolino. Just tan x, good, because the cos y's, they just cancel each other out, don't they? Cos y cancels. We're left with tan x plus, what does the other one, the one to the right of it, what does that simplify to? Not tan x, Faham, good. But 0, good. The cos x cancels. We're left with sine y over cos y, tan y. Divided by. What about this one here? What does that simplify to? Look carefully. Tanny. What is this one simplifying to? 1. Nice. Everything just goes. Cos x over cos x, cos y over cos y. It's left with 1 minus. Now, this is an interesting one. What do you think this last one simplifies to? Nice. Tan x, tan x, tan y. Look at that. Easy. So using that idea, can you guys predict what tan of x minus y would look like? How does that affect what we've just done? So I'm very simple. Nice, SV. The signs just switch. So remember the numerator is always sine, right? It keeps the sine the same. So it has to be a minus, same as the negative tan. But the denominator is always cos, which changes the sign. So it becomes 1 plus. And there you go. So it looks like this stuff is hard. But actually, when you go through the basics, where does this stuff come from? It's actually quite simple. Yeah, Golden State. Swapperoonies and that. Okay, so these are the addition rules. Okay. Now, the way if you look at the SV, that's something that we learned in year 12. So I'm not going to go over that again. So here you can see for sine, the sine stays the same. For cosine, can you see the sign flips? It just switches around. You look at the top and the bottom. Okay. So can you see the top sign here? is plus, it means when you do the expansion, it changes to minus. Okay, so that's just what the expression is saying. Okay, so check out this question. It's another common exam question. It says, given that 3 sine x minus y equals 4 cos x plus y, express tan x in terms of tan y. So when you guys see something like this and they want tan x, tan y, what should we be doing first? What do you think step 1 is? But zero, it's all trigonometry. So mainly just solving with trig. We can also use it when we model with parametric. Sorry, I got hiccups for some reason, but we can also use it when solving with parametric equations, modeling with parametric equations, all that good stuff. So now this is just exam technique. When you see something like this, exactly, Faham, we're going to use the addition rules. And then Bazira, maybe we'll do that. But first, because they want tan x and tan y separately, we notice that here x and y are trapped within the angle. So we need to use the addition rule. Okay, so again, to reiterate, guys, the addition rule for sine, how do we remember it? What's the format? How do you remember the addition rule for sine? How does it go? You don't have to write the whole thing. It's more so how you remember it. Farham, good. Sine, cos, but zero exactly. The only difference here, guys, is the coefficient is 3. So it goes 3 sine, cos, and then 3 sine, cos. I've written that so big that I'm not going to have any space. All right, let me do that again. You guys should have more space. I'm actually going to write down here then. So I have 3 sine, cos, 3 sine, cos. I get xy, yx. Sine does what to the sine? Sine does what? No, not change. Keeps it the same. Sine keeps the sine the same. Okay? Equals. How do you remember cos? It's all phonics. All of this stuff is just phonics. This one's cus. Okay, but the coefficient's 4. 4 cus. And then we have 4 sine. Okay, so we have xy. Nothing changes there. And then yes, cos changes the sign. There we go. Easy. The addition rules are very simple to remember. But now we need to turn everything into tan x and tan y. What did we do in the last example to convert everything to tan x and tan y? What did we do everywhere? Don't go anywhere. What did we do in the last example? Divide by cos. Can you be even more specific here? But zero, I know what you mean. Divide by cos x and cos y, Nathan. Good. So guys, we need to divide by both cos x to turn everything into tan x, and we need to do cos y. Okay. Term 1. What does term 1 simplify to then? What does term 1 simplify to? SV3 tan x. See how you guys were really scared at the beginning and now you guys are in your flow? That is true. The cos y's do cancel. Good. And then we're left with 3 sine over cos, which is 3 tan. Minus. All right, what about term 2? It's always the case that the theoretical side of things might look very intimidating, guys. But in practice, this use is so simple. Yep, minus 3 tan y. The cos x's cancel. Sine over cos 3 tan y. Equals. All right, term 3, what's that? Be careful. Just 4, right? Because the cos x's and cos y's cancel. So just 4. Minus, what about the 4th term, the final one? But 0, good. So we have minus 4. Sine over cos is tan x. Sine y over cos y, tan y. Good. Now, the final thing is it says to express tan x in terms of tan y. Are we rearranging for tan x or tan y? Yeah, Ibrahim. True that, true that. Yeah, we're rearranging for tan x. Good. SV. 0, yeah. Express tan x in terms of tan y. So we just need to bring the tan x's to one side. I see the 3 tan x here. And I see the minus 4 tan x here. I'm going to bring that to the right side. So it's going to come here. And the minus 3 tan y can go over here. Okay. Be careful though, Bazira, because the minus 4 tan x has a tan y attached to it. So it actually becomes 3 tan x plus 4 tan x. That could be my fault because I just highlighted the minus 4 tan x. Tan y equals 4. Then that minus 3 tan y becomes plus 3 tan y. Golden State Warrior. Everything starts next week. Year 9, I'm not sure which day it's on, but all next week. Then we factorize out tan x. So we get 3 plus 4 tan y is 4 plus 3 tan y. And there we go, guys. We're done. We just need to divide through by the bracket. So we get 4 plus 3 tan y over 3 plus 4 tan y. See a Golden State. And that's it. So this could be like a cheeky 4-mark question in a real exam. 3 or 4 marks. Okay. There's definitely some nursery entrance exam type stuff. For real. All right. So there you go, guys. There's an example of a exam type question. The last one I want to go through is another one. In the main course, this is only like maybe like half of the full lesson. We go into like really hard solving questions. Neil, go home and sleep. What do you mean? Why do I need to go home and sleep? Do we have to do 4 squared plus 3 squared, then square root? Farham, that's our transformations, which we're not doing just yet. That's a different topic that we would do after this one. So, yo, Aniv, I look mega tired. What do you mean? Hey, oh, nah, that's just the camera. It's all bugging. I'm always awake, yeah? Gotta get on a Jubilee line after this. Using a suitable expansion, show that cos of 105 degrees is root 2 minus root 6 over 4. Okay, using a suitable expansion, it is trig. The only expansions are the addition expansions. So you're going to have to rewrite cos of 105 as the addition of angles that we are familiar with. Going back to what we did at the beginning, guys, when we did that counter example. Give me 2 angles that we should be familiar with that add to give you 105 degrees. Which 2 angles are those? So it can only be common angles. So SV is saying 60 and 45. Nathan, for year 13 content, all the exam boards are the same. Further maths, they start to change. But SV is correct there. So for 105, yeah, what 2 common angles add to 105 is 60 and 45. And now we need to do the addition rule there. Okay, guys, how do we remember the cosine addition rule? How do we do that one? Dive. Couscous. Good. And cos does what to the sine? Good. Couscous. Flip the sign. Change the sign. Cos. Instead of saying flip, I know what you mean. Cos changes the sign. So we have 60, 45, 60, 45. Cos changes the sign. Now, it's not like GCSE where you have non-calculator papers. Yeah, so here we have access to the calculator, but they would want to see this, okay? You need to show all this working out. Now, cos of 60 is a half. Cos of 45 is root 2 over 2. Yo, param. Minus sine of 60, which is root 3 over 2. Times sine of 45, which is root 2 over 2. Okay? This first term here is root 2 over 4. Minus root 3 times root 2 is root 6 over 4. And there you go, guys. When you simplify that, everything is over 4. We get root 2 minus root 6. And that's it. Guys, that's the additional rule. How does it feel now compared to the beginning? I usually jump straight into it. You know, it usually goes really intense, cheeky. Hey, Anaya. So it usually starts very intense because I'm proving things to you. Guys, by proving things to you, you build that trust with me. Okay, it's very important that there's a lot of trust between student and teacher. Because then anything I tell you afterwards with regards to the maths, you believe me, okay? But you can see the applications of all of this stuff is very simple. It's just this stuff, obviously, when you prove stuff can be quite crazy. But the applications of things are very simple. It's very important you understand where the formula comes from, okay? You might find when you start year 13, your teacher's just going to tell you stuff. I don't believe that's a good way of teaching, okay? Believe a guy that benches 3 plates. For real, man. I'm not sure, Ibrahim. They happen as of when the team allow it. Okay, so, and if